Next question, capital R is defined as ordered pair of A comma B, whereas A less than or equal to B cubed. Verify that whether it is reflexive or symmetric or transitive. Okay, the main set is capital R. It is real number set, real number set. Next, R, capital R is defined as ordered pair of A comma B so that A less than or equals to B cubed. This is capital R. Actual meaning is capital R is a subset of R cross capital R. Of course, capital R cross capital R, it contains infinite elements. Each element is one ordered pair. From that infinite set, he has chosen the ordered pair of A comma B so that the first coordinate is less than or equal to cube of second coordinate. This is the complete meaning. Okay, I am asking that is A less than or equal to A cubed? This is my question. Yes or no? No, because answer is no. Because -2, -8, these are belongs to real number set. Okay, -2, according to this, let us take a letter A is equal to -2. -2. According to this, -2 less than or equal to -2 whole cubed. That is -2 less than or equal to -8. But it is false. It is false. Therefore, A not less than or equals to A cubed. So, what does it mean? Ordered pair of A comma A not belongs to this capital R. This capital R. Therefore, R is not reflexive. R is not reflexive. Okay, this is first one. Next, test for symmetry. So, number 2. So, let ordered pair of A comma B that belongs to capital R. Means what? Means A less than or equal to, according to this, B cubed. So, when A less than or equal to B cubed, then B should not be less than or equal to A cubed. You can take one example. For example, A is equal to 1, B is equal to 2. So, what is happening? 1 less than or equal to B cubed means 2 cubed, 8. So, in such a case, is it true? B means 2. 2 less than or equal to 1 cubed. So, 2 less than or equal to 1. But it is false. It is false. So, therefore, whenever A less than or equal to B cubed, then it is not possible to say B less than or equal to A cubed. Hence, B not less than or equal to A cubed. So, that implies B comma A not belongs to capital R. Therefore, capital R is not symmetric. 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 Next, number 3. Next, number 3, transitive. Number 3, transitive. Number 3, letter A comma B that belongs to capital R and B comma C belongs to capital R. So what does it mean? According to given condition, first element is less than or equal to cubed root of second element. What does it mean? First element is less than or equal to cube of second element, C cubed. Now, now, listen once again. If A comma B that belongs to R, then first element less than or equal to B cubed, second element whole cubed. That's why let us consider A less than or equals to B cubed. So that implies A less than or equal to cubed. Same. B is what? B is less than or equal to C cubed. So A less than or equal to C power 9. 3 3s are 9. So that is not equals to C cubed. Therefore A not less than or equal to C cubed. So that implies ordered pair of A comma C not belongs to capital R. Therefore R is not transitive, or is not transitive, or is not transitive, or is not transitive. Hence the problem. So that the relation capital R is equal to set of 1, 2, 2, 1. In the set 1, 2, 3 is only symmetric but not reflective, not transitive. This is the question. Actually, what is the complete meaning? Capital A is equal to the set of, let it be the main set hypothesis. Capital A is equal to 1, 2, 3. Okay. N of A is equal to 3 elements are there, number of elements in capital A. Next, what about N of A cross A? That is equal to 3 into 3, that is equal to 9. Next question, the number of subsets equal to 2 power formula N of A cross A, that is equal to 2 power 9. 2 power 9 means it is 512. 512 subsets are there for A cross A set. So therefore, number of subsets of A cross A is 5 and 12. 5 and 2. 5 and 2. So already we did know the definition of the relation. Relation means what? Each and every subset is one relation. Each and every subset is one relation. So therefore, how many the number of relations from capital A to capital A will be 5 and 2. 5 and 2. Out of 512, it is only one. That is what? The set of 1, 2, 2, 1. Once again, out of 512 sets, one set is given. Its name is capital R. This is the complete meaning of question number 6 in NCERT textbook. Okay. Now, what is the question? Show that this R is only symmetric. 1 minute. Capital A. Actually, 1 belongs to capital A. You see the definition of reflexive there. This is the definition of reflexive. So that's why first take 1. 1 belongs to capital A. Is 1 comma 1 that belongs to capital R? Question mark. Answer, no. Therefore, for first element it is failed. Therefore 1 comma 1 not belongs to capital R. Of course, 2 comma 2 not belongs to capital R. 3 comma 3 not belongs to capital R. Therefore R is not reflexive. R is not reflexive. Next, symmetric. For symmetric, number 2. So first take first element. 1 comma 2, that is belongs to capital R. Capital R. So I am asking that is reverse 2 comma 1. 2 comma 1 belongs to again capital R? Question mark. Yes. Answer is yes. Therefore for 1 comma 2 belongs to capital R, 2 comma 1 is also belongs to capital R. Therefore you come here. B, if A comma B belongs to capital R, then B comma A is also belongs to capital R. It is called symmetricity or symmetric relation, symmetric definition. So therefore capital R is a symmetric relation, symmetric relation on capital A. You can write A cross A also. Okay. Next, number 3, transitive. 1 minute. Let us verify another element. First element is over. Next, take second element. Second element. 2 comma 1 belongs to capital R. Capital R. My question is reverse. 1 comma 2 again belongs to capital R? Question mark. Our answer is yes. Therefore, if 2 comma 1 belongs to capital R, then 1 comma 2 is also belongs to capital R. Hence R. So for first element, for second element, for all elements of capital R, it is verified. Therefore R is symmetric. R is symmetric. So we have to take all the elements in capital R. This is the procedure of showing symmetric relation. Next, transitive. Next, number 3. You come here. Transitive. If A comma B and B comma C belongs to capital R, then A comma C is also belongs to capital R. Then R is transitive. Here, 1 minute. Another one remark is there in transitivity. So first element A comma B. So what I am telling that, in other words, if A comma B and B comma C, that is belongs to capital R, then A comma C is also belongs to capital R, then it is a transitive. So one remark is there. Remark. Even if B comma C, alternative pair of B comma C, not belongs to or does not exist in capital R, then also capital R is transitive. It is one remark in transitivity. You come here. Here, 1 comma 2. So first element 1 comma 2. Like that. We are taking A comma B. Second element B comma C. Second element B means starting with 2. Starting with 2 element is there? Yes. 2 comma 1. Okay, 2 comma 1, that is belongs to capital R. Next, it is in the form of A, B, C. Okay, B, same. Then is it implies 1 comma 1, A comma C. That is belongs to capital R? No. So we can write that is not belongs to. Or we can write belongs to. We can strike out implication. We can write like that. Therefore R means what? This condition is failed. Therefore R is not transitive. Therefore R is only symmetric, neither reflexive nor transitive. Hence the problem. Show that the relation capital R in the set So main set given capital A is equal to the set of 1, 2, 3, 4, 5. Next, actually capital A, n of A equal to 5. N of A cross A equal to 5 into 5, 25. The number of subsets equal to 2 power 25. So number of relations equal to number of subsets of A cross A, means it is 2 power 25. Out of 2 power 25 sets or subsets or relations, he took one relation. What is that? In that relation, the elements are like that. Modulus of first coordinate minus second coordinate is even. Its name is capital R. This is the question. First question. We have to show that R is an equivalence relation. This is the first question. Okay. Let us prove the first question. Here. First, for reflection. Okay. Modulus of A minus A. Modulus of A minus A equal to 0. 0, it is an even number. Even number. Therefore, or that follows, ordered pair of A comma A. Instead of B, I put A. It is called ordered pair of A comma A belongs to capital R. Therefore, capital R is reflexive. Capital R is reflexive. Okay. Number 2. Let ordered pair of AB, that is belongs to capital R, means what? Modulus of A minus B is even number. So what does it mean? Modulus of B minus A is also an even number. How? One example. Modulus of 2 minus 4 is equal to modulus of minus 2, that is equal to plus 2. It is even number. Similarly, modulus of 4 minus 2, that is equal to 2. It is also even number. So whenever A minus B is even, then B minus A is also even number. Thus, that implies ordered pair of B comma A is also belongs to capital R. In this relation or set, all are even numbers. Therefore, if this is even, definitely this kind of ordered pair is again in capital R. So therefore, A comma B that belongs to capital R, that implies B comma A is also belongs to capital R. Therefore, capital R is symmetric relation on capital A or A cross A. Instead of writing A cross A, simply we are writing on capital A. Okay. On capital A means what? Capital R is subset of A cross A. Subset means one relation. Okay. Next, number 3. Transitive. Let A comma B, look at the board. Let A comma B that belongs to capital R and B comma C that is belongs to capital R means what? Modulus of first element minus second element is even. Even means that is A minus B is also even. Here, modulus of B minus C is even number. That is B minus C is also even number. Here. Next, now let us consider A minus C. A minus C can be written as A minus B plus B minus C. We can write like that. It is nothing but adding B, subtracting B. So no loss of generality. So on cancelling B, we are getting the same A minus C. Therefore, A minus C can be A minus B plus B minus C. So A minus B even number plus, already I said A minus B is also even number. B minus C is also even number. So A minus B even number, B minus C is even number. So even number plus even number, it is even number. Therefore, whenever A minus C is even number, then modulus of A minus C is also even number. According to given hypothesis, ordered pair of A comma C is also belongs to capital R. Therefore, if A comma B and B comma C, that is belongs to capital R, then ordered pair of A comma C is also belongs to capital R. It leads to R is transitive. It leads to transitive. R is transitive. So one part is over. Next, second part, show that all the elements of 1, 3, 5 are related to each other. This is the second question. Related to each other means, so second part. This is the second part. This is first part is over. This is first part. Next, this will be second part. So it is first part. Second part, show that all the elements of set of 1, 3, 5 are related to each other. Related to each other. Means what? We have to show that 1 minute, 1, 3, 5. Modulus of 1, 1, 3, 5. So modulus of 1 minus 3 is what? Minus 2 plus 2. Even. It is even number. Modulus of 1 minus 5 is what? So what does it mean? Ordered pair of 1, 3 is belongs to capital R. Next 1, 5. So 1 minus 5 minus 4. Modulus of minus 4 plus 4. It is also even. Thus 1, 5 is also belongs to capital R. And similarly 3, 1. 3, 1 is also belongs to capital R. Here also similarly 5, 1 is also belongs to capital R. 3, 1 belongs to capital R means what? Modulus of 3 minus 1 is also even number. Here modulus of 5 minus 1 is also even number. So 1, 3, 1, 5. 1, 3, 1, 5. Next 3, 1. Next 3, 5. Modulus of 3 minus 5 is what? 3 minus 5 minus 2. 2. It is also even. So what does it mean? 3, 5 is also belongs to capital R. And similarly 5, 3 is also belongs to capital R. So 1 minus 3 even. 1 minus 5 even. 3 minus 1 even. 3 minus 5 even. 5 minus 1 even. 5 minus 3 even. So all are even numbers. Therefore that ordered pairs all belongs to capital R. Thus the set of 1, 3, 5 are related to each other. Reason even. It is modulus of 3 minus 1 is also even. Modulus of 5 minus 1 is also even. Modulus of 5 minus 3 is also even. If any one condition is failed, definitely here we are writing are not related to each other. Okay, because of all differences under modulus are even. That's why it is possible to write like that, related to each other. Okay, second one is over. Next, third one. And all the elements of 2, 4 are related to each other. This is the third question. So similarly Third question. Given set is the set of 2, 4. Same procedure. Here, modulus of 2 minus 4, that is equal to 2. 2 minus 4, minus 2. Modulus of minus 2 plus 2. It is even number. It is even number. Similarly, modulus of 4, 2 minus 4 even. Next 4 minus 2. 4 minus 2. It is also even number. Therefore, same result. All the elements of therefore all the elements of the set of 2, 4 are related to each other. Next, last question. But no element of 135 is related to the set of 2, 4. This is the fourth one. This is fourth question. So, look at the board. Next, number 4. So, first set, let it be capital A is equal to the set of 135 and capital B is equal to the set of 2, 4. Just you calculate or find modulus of first element 1 minus 2, that is equal to 1. It is not even. At first it is failed. That modulus of difference is even. It is failed. So therefore, no element of the set of 135 is related to any element of the set of 2, 4. If you want the complete proof, I will write here 1 minus 2 not even. Next 1 minus 4, modulus of 1 minus 4, it is not equal to even. Next with 3, this 3 minus 2, 3 minus 4, modulus of 3 minus 2 is not even number. Similarly, modulus of 3 minus 4 is not an even number. Next with 5, modulus of 5 minus 2, is not even number. Similarly, 5 minus 4, modulus of 5 minus 4 is not even number. Thus no element of set A is related to any element of capital B. Hence the problem. Actually, this question contains 4 sub problems. Hence the problem.